We're going to look at the scenario here for problems numbers 5 through 11. I've gone ahead and circled some of the important information. So Mr. Pinkertinker needs to rent a car. The rental company charges a flat fee of $55 plus 50 cents a mile. Any partial mile driven is rounded up to the nearest mile. So on the accompanying graph page, create a graph of the scenario, label your axis, and include words to describe what each axis represents. So we know that the amount of money he's going to pay depends on the number of miles he's going to drive. So the x-axis is the number of miles driven, and the y-axis is the amount of money that he ends up paying. So I've scaled this by 5, so 5, 10, 15, 20, 25, 30, and so on, labeling every $10. Now, to draw a graph of the scenario, we know that the starting fee is $55. So our starting point when he hasn't driven at all is $55. So I'm going to put a point here. Then I need to figure out how to scale the miles. So I'm going to go ahead and just scale it the same way I scaled the y-axis by 5. So 5, 10, 15, 20, 25, 30, and so on. Okay. Now for each mile he drives, he gets charged 50 cents. So rather than going by ones, we went by fives. So if I go ahead and skip to the 10-mile mark, for example, for 10 miles, he's getting charged 50 cents for each mile. So that would be a total of $2. Or not $2. 10 times 50 cents would be $5 extra on top of the 55. So at 10, he gets charged another $5. So that would be at 60. Now if he drives 20 miles at 50 cents a mile, that's a total of another $10. So starting at 55 and adding another $10, we would get here. So you can kind of see the pattern. For every 10 miles, he'll get charged another $5. And so on. So we have a graph of a line. Now on number 6, write an equation that represents the company's rental fees. So y equals, he's getting charged 50 cents a mile, so 0.5 times the number of miles plus the starting fee of 55. How much would it cost to rent a car for a 195.7 mile road trip? So any partial mile driven is rounded up, so I'm going to round this to 196 miles. Using our equation, we can calculate how much it would cost him. So 50 cents for each mile plus 55 miles. And we can go ahead and just type that into our calculator. So 0.5 times 196 plus 55 is $153. Okay, Mr. Pinkertinker only has a budget of $100 to spend. What is the furthest distance he could drive? Pardon me. So he has $100 total, so that's the y value. And I'm going to work backwards to figure out how many miles he could drive. So solving this equation, I'm going to subtract 55 from both sides, so that's 45 equals 0.5x. And then divide by 0.5. So 45 divided by 1/2 is 90 miles. State the domain of the scenario. Justify your answer in context. So our domain, in this case, is asking for what x values are on the graph. So we know that if he drives 0 miles, he gets charged $55. So 0 is the minimum number of miles he could drive. He could drive anywhere up to 90 miles because he only has $100 to spend. Could he ever be charged exactly $85.25? Explain how you know. So we know that any partial mile driven is rounded up. So let's go ahead and check whether we would ever get a total cost of $85.25 by looking at the equation and working backwards. So 0.5x plus 55. I'm going to subtract 55 from both sides. 85.25 minus 55 is 30.25. And then I'm dividing by 0.5 on both sides, which is 60.5 miles. So since the partial miles get rounded up, they're never going to charge him for 60.5 miles. So this is going to be no, based on the work that I showed here. Alright, does your answer to number 10 imply that the range of this function is discrete or continuous? Explain. So this implies that the range is discrete because he's never going to get charged $85.25. He's going to get charged for rounding up the number of miles. So he would be charged for 70 miles, not for 60.5 miles.